We're going to be looking at problem 167, 2 sum 2, input array is sorted. Jumping into the code visualizer, let's remember the 3 steps of solving any problem. 1, understand it. 2, visualize it. And finally 3, implement. So, given a 1-indexed array of integers numbers that is already sorted in non-decreasing order, let's break that down. 1 index means that, so usually arrays are 0 index, meaning that the first number, its index is 0. Here we're saying that it's the first number's index is going to be 1. And then sorted in non-decreasing order means it's going in ascending order. Okay, let's carry on. Find 2 numbers such that they add up to a specific target number. Let these 2 numbers be numbers index 1, numbers index 2, where 1, so where the 2 indexes are between 1 and the length of the numbers. Return the indices of the 2 numbers index 1 and index 2 added by 1. Added by 1 just means it's just a redundancy saying that it's 1 indexed as an integer array index 1 index 2 of length 2. The tests are generated such that there is exactly 1 solution. You may not use the same element twice. And finally, your solution must use only constant extra space. So if you try to use extra data to keep track of what numbers you've used before, like you're not allowed to do that in this case. Don't store any data anywhere. Looking at the constraints we have, in addition to what we've already seen, is that the length of the numbers is between 2 and 3 times 104. Numbers I, so any given numbers between negative 1,000 and 1,000. Once again, they're saying that it's the numbers are in increasing order, and target is between negative 1,000 and 1,000. And once again, they're saying that there's going to be 1 solution for any given problem. So let's jump into it. So let's look at example 1. So we start with 2, 7, 11, 15, and the target is 9. So we see that 2 and 7 do add up to 9. So yeah, you have 2 and 7. So how can we get to that number? Like, these aren't necessarily the best examples to try to visualize this. So let's just create our own situation. So let's say 1, 2, 3, 4, 6, and 8. So let's say, well, give me the 2 numbers that add up to 8. Okay, so feel free to stop the video at this time and just think about it. Okay, if you've thought about it now, we want to say that 2 and 6 add up to 8. But how can we get to that solution? So usually when you're thinking about it's kind of like 2-pointer problem where you have an I iterator and a j iterator. It could be A iterator, B iterator, you name it whatever you want. You can either move things, in the same direction, so left to right or maybe right to left, or you can move them in contrary direction. If you thought that contrary direction is the way to go, I would agree. It becomes a very trivial problem if you start with I is at 0 in the 0 index and j at the furthest to the right of the array, because say 1 and 8 is 9. It's too large. We're looking for number 8. So the 8 on the right, let's bring this down a notch. 1 and 6, now it's actually too low. We're trying to get to number 8. So let's move I up 1. And look, now we have 6 and 2. We didn't store any extra data in memory, and we got to the final solution. And this is all you need to know to implement a final solution. So let's go ahead and just do that in JavaScript. So what did we do? We have 2 iterators. In this case, I'm gonna call them, I guess just to keep pace, let's call it let I, and let I is 0, because we're gonna use 0 index, and then let j equals numbers, the length minus 1, and let's use a while loop while I is less than j, so we don't want to overlap our indexes. We can just so what do we do? We saw, looking at our example again, we started off with I is 0, j is length minus 1, and we had a sum which was 9. So let's create that scenario. So sum is numbers I plus numbers j. So in this case, it was 9. It was too large. So if sum is greater than target, what do? We move j down 1. Else if sum is less than target, so we had 7, if you remember. Oh, let me just move this down. Okay, 7, it was too small, so we need to move I up 1. Otherwise, we've actually found the solution, and we can go ahead and return the answer. And the only trick here is to make sure to index this, use a 1 index, so just add 1 to your indexes. And let's see if I got this. Yep, there you have it. So yeah, thank you.